Good morning students, welcome back to computer science classes of class 12. Today we are going to start with the second unit, that is computer networks. Let us have a look what are the different topics that is there in the syllabus of computer networks. It is evolution of networking, data communication terminologies, transmission media, network devices, network topologies and types, network protocols, mobile communication technologies, then electronic mail protocols, network security concepts, introduction to web services, e-commerce, payment transactions using online banking, mobile banking, payment apps and services. Now let us see what are the topics that we are going to cover for this session. It is evolution of networking, which will be including ARPANET, internet, interspace, different ways of sending data across the network within reference to switching techniques, that is circuit and packet switching. Let us start with the evolution of networking. At first we should know what is a network. A network is any collection of independent computers that communicate with one another over a shared network medium. Or you can say it is a collection of two or more computers linked together for the purpose of sharing information and resources. So network is nothing but connection of two or more network devices. Moving to next, why do we need this networking? Why can't we work with only a standalone PC? The first reason is resource sharing. For the resource sharing, we can share the files and softwares. We can share some peripherals. For example, a company which is having 50 computers and just have some like 2 or 3 printers, then at that time what we can do, we can have a networking and just share the resources among those 50 computers. And the last one, we have got sharing storage. On a network you can access data from one machine to another. Okay, so that is your sharing storage. The next reason why do we need for this networking, first is improving communication. Like all of you know, we have got now lots of techniques with which we can communicate with one another without having a face-to-face contact, like your instant messaging, emails, video conferencing and so many other techniques. The next one, we have got access to remote database. Remote database as in, suppose you are sitting at your home and you want to access some data from your school's computer PC. Then if your computer can be connected to that server, that PC, through Telnet protocol, then that is remote access. So sitting at home, you can just have a control and access those data from the computer of your school. Then that will be your accessing remote database, and it will help you just reducing your carriage cost or traveling cost, right? Sitting at home only you can perform any task. Now what is the disadvantage of this network? When anything is having a positive side, it must be having a negative side. So not only studying positive side, we should also know the negative portions. First, it is threat to data. The data are not that secure. If we do not properly have our security, file security, then the unauthorized users may steal or corrupt your data. And very important, it is very difficult to set up. Like everywhere, the systems on the network are more sophisticated and complex to run. So sometimes setting up a network becomes an difficult task for the persons. Now let us see what was the story behind the evolution of network. As all of you know, what is ARPANET? ARPANET stands for Advanced Research Projects Agency Network. So the story is, in 1969, the first network, that is ARPANET, was developed by US Department of Defense, and the goal was to connect computers at different universities and US defense. Then after that first network, in mid-80s, the National Science Foundation created a new capacity network called NSFNet. NSFNet stands for National Science Foundation Network, which allowed only academic research on its network. After that, every small companies tried to have their own networks, which were later interconnected along with ARPANET and NSFNet to form Internet. And a network forming by linking these two networks or more than two, that is NSFNet, ARPANET, and the small networks of different companies, it was called as World Wide Web, which is now we call it as Internet. I hope all of you have understood how this networking has evolved. Now let us learn what is Internet. As we know, Internet is interconnected network. So we can say it is a system of linked networks that are worldwide in scope. And what are the facilitations or what are the advantages of Internet? It facilitates data communication, right? Then it also helps us for remote login, transfer of mails, messages, instant messaging. Then we can contact with anyone sitting at home. Maybe that next person is sitting at America or any corner of the world. Then we have got separate protocols for exchange of information and those set of rules with which we can govern the communication, that is called protocols. For example, TCP/IP, FTP, and many more. Moving to next, what is this interspace? Interspace is a client-server software program that allows multiple users to communicate online with real-time audio, video, text, chat, dynamic 3D environments. So interspace is nothing but which allows our communication online. Okay. It also provides the most advanced form of communication technology, like we are doing video conferencing nowadays. So that is actually interspace. Now, what are the requirements of a network? First, at least two computers, that is server or client workstation. Then your NIC, the network interface cards. Then your connection. Obviously, if you do not have a connection, then how you can have it? The connection medium is very important, or you can say the transmission medium. And then the last one is network operating system. This network operating system can be Linux, Unix, or NetWare, or Microsoft Windows NT, Microsoft Windows 2000, anything. Now let us understand some terminologies related to network. First, nodes. These nodes are also known as workstations. A computer becomes a node as soon as it is attached to a network. So your PC, my laptop or my PC, everything which is connected to internet or which is connected to one another, so that is a node only. But what is the server? A computer that facilitates sharing of data or software and hardware resources on the network, that is a server. Or you can see a network can have more than one server. So each server has a unique name which is identified by all the nodes of the network. So server is the host, you can say it is the host computer which is actually giving all the connections. Moving to next, we have got some types of servers. First we have got dedicated server and another one is non-dedicated server. The word dedicated means it is specific to a particular task. So dedicated servers are used in big networks, okay, where suppose one computer is reserved for a server job and it helps all nodes access data, software and hardware resources. Since these dedicated servers do not double up as a workstation but only manages the network, so that's why it is called as dedicated server. Got it? It is not working as the client also. It is just working as the server only. It is only helping the clients to work, to manage the resources. And that's why such type of networks is also known as master-slave networks, because the server is acting as a master and the rest of the client computers are acting as a slave. Moving to next, we have got non-dedicated servers. Non-dedicated servers are used in small networks where workstation can double up as a server. And such type of non-dedicated servers are used in peer-to-peer networks wherein every client can be considered as a server at times. Okay. And the last one is network interface unit. The network interface unit is a device that is attached to each workstations and server, which helps to establish communication between server and workstation. So this network interface unit is very important for having an internet connection, for having a networking between the client computer and the server computer. And suppose the standalone computer becomes a workstation, it needs an interface to help establish connection with the network, because without these workstations will not be able to share network resources. So this is very important for communication and resources sharing. The last important line is this network interface unit can also be called as network interface card, which actually acts like an interpreter, which is also known as terminal access point. And this NIC is manufactured and assigns a unique physical address. And this physical address is also known as MAC address. Now let us learn what is switching techniques. Switching technique is used for transmission of data across one network to another. So across the networks, if you want to transfer your data, then we have to learn the switching techniques, which are very useful for transmission of data. There are two different types of switching techniques. First is circuit switching and the next one is packet switching. We will learn them one by one. Let us first learn what is circuit switching. A circuit switching is a technique in which a dedicated physical connection is established between two nodes. So dedicated physical connection means before transmission of data, the network connection is been established, and then the circuit guarantees the full bandwidth of the channel and remains connected for duration the communication is done. Throughout the communication session, it is done. For example, suppose you have called someone. It has been, make sure that your call is connected to the next person and then you start speaking. And until your whole conversation, the connection is on. The connection is on. After you complete it, and then the connection is disconnected, right? So this is very important for your telephone network and all. So I hope the circuit switching is clear to you all. I'll repeat again. The circuit switching has got a dedicated and complete physical connection. So before transferring of any information from one network to another, there has to be a dedicated connection. There has to be a connection established. Then only the transfer is taken place. And throughout the communication session, throughout the transfer of data, this connection is been there. It cannot be disconnected. Once it is disconnected, the communication can be lost or the session can be interrupted. The best example for circuit switching is the telephone network. The next we have got packet switching. Packet switching is a switching technique in which packets are routed between nodes over data links shared with other traffic. Or you can say, in packet switching, there is no dedicated connection as we have seen in the circuit switching. What happens over here, packet switching? The information that is to be transferred is first divided into small packets. And then each packet is sent onto the network. And each packet will be having some header or some information onto it, that to which destination it has to be and from where, from the source and the destination. Addresses are been given on the header of that packet. And then each packet is streamed up independently. After that, these information are received by the destination, and then depending upon the header, they again sequenced. The sequence is maintained again, and after that, what happened? They complete that whole sequence, and then they send an acknowledgement to the source. In this way, the packet switching is working. Now let us have a proper difference between the packet switching and circuit switching. First, as we know, circuit switching is connection oriented, whereas packet switching is connectionless. And very important, circuit switching was first created or designed for voice communication, whereas packet switching is designed for the data transmission. Then flexibility. Circuit switching is not that flexible because once a path is set, all parts of a transmission follows the same path. But packet switching, it is very flexible because a route is created for each packet to travel to the destination. For example, if I am using circuit switching, once I have told I have to move from here to school through SBI line, so I have to every time follow that route. But if it is packet switching, I can go from my home to school through SBI line or police line or Kerala line or anywhere. So that is your packet switching. That is very flexible. You don't have to focus or follow a particular route. Then in circuit switching, message is received in order and sent from the source. So in the particular order it is sent and in particular order it is received. But in packet switches, what happened? The packets of a message are received out of an order because there is no particular order that has been maintained. Only the header is having that particular sequence number, that this is the second sequence, this is the third one, this is the fourth, fifth part, this is the fifth part. When they have received, maybe the first one has, maybe the second part has received by the receiver at first, and then the third one received at last. So the whole thing has got jumbled up. So what the receiver has to do, they has to again assemble it in a particular sequence that has been given at the header of that packet. Now this circuit switching is implemented at physical layer of OSI, whereas packet switching is implemented at network layer of OSI. Now let me first tell you what is OSI. OSI is a standard interconnection network or standardization. Okay, open systems interconnection or information interchange. So this is nothing but, it is having 7 layers. The whole network system is divided into 7 layers that we can learn, like P, D, N, T, S, P, A. This P is the physical layer, D is the data link layer, N is for network layer, T for transport layer, S for session layer, S for session layer, P for presentation layer, and A for application layer. So the circuit switching is working on physical layer, and whereas packet switching is working on network layer. I hope the circuit switching and packet switching is clear to you all. With this, we are completing the evolution of computers, evolution of networks, pardon. So that is, if you have any doubt throughout this whole session, you can send me message or we can have a conference call. Thank you and stay tuned with the upcoming slides.